We will give a presentation about colorectal diagnosis. Today's agenda is as follows. First, let's talk about colorectal diagnosis by white light imaging. Colorectal lesions are divided into epithelial tumor and non-epithelial tumor. Today, I will talk about epithelial tumor. Epithelial tumor includes hyperplastic polyp, SSL, adenoma, and carcinoma. I will discuss each of the key points of observation by white light imaging. First, location. In the case of the rectum, distance from anal bulge and predominant wall are important. Anal bulge to Hermann line is 3 to 4 cm apart. Anal bulge cannot be confirmed by inverted observation of the rectum. This is dental line. This is Hermann line. The region is located in the rectum. The region is 0 cm from Hermann line and 3 to 4 cm from anal bulge. In the case of this region, it is located on the left wall of the rectum. In the left lateral position, 6 o'clock is the anterior wall, 0 o'clock is the posterior wall, 3 o'clock is the right wall, 9 o'clock is the left wall. Next, about lesion size. Lesion size is determined by rough visual inspection, but if you want to measure lesion size actually, we use non-traumatic tube. Non-traumatic tube diameter is 3 mm. So, this lesion size is about 6 times larger than tube, so 18 mm. Next, color and macroscopic type. Based on height only, divide the surface type into rise type 1 and surface type 2, and further divide the surface type 2 into surface rise type 2A, surface flat type 2B, and surface depressed type 2C. Type 1, 2A, and 2C have an adenoma-carcinoma sequence, while type 2C has a de novo pathway. Type 2C lesions, which are de novo cancers, are a direct route to colorectal cancer. We refer to superficial tumor larger than 10 mm as LST, which are classified into two groups as LSTG and LSTNG type. LST increases SM massive rate as size increase. LSTGH has low SM massive rate even for larger size lesions. On the other hand, LSTNGPD has high SM massive rate for even small size lesions. The skirt extended along the margin of a LSTGM and is hardly elevated flat region with a dilated pit pattern. Identification of the skirt in rectal LSTGM. Macroscopically, the region consisted of not only the aggregate small and large nodules that are typically seen in LSTGM, but also hardly elevated flat component. Magnifying endoscopy using indigo carmine dye showed a wide pit. There was no mesh capillary vessel observed when using NBI. The skirt region consisted of atypical tubes with goblet of various size, which different from adenomatous or hyperplastic tubes. Various appearances are found in the skirt. LSD with the skirt were associated with a significantly higher recurrence rate. Multivariate analysis demonstrated that the presence of the skirt and piecemeal resection was significantly the predictor of rectal recurrence. In this case, the border was not so clear on the observer's left side even after angiocalamine staining. The arrows show the border between the skirt region and the normal mucosa. Such regions require attention during ESD. Advanced histology was significantly associated with loss of lobulation, heterogeneity in mucosal pattern, non-polypoid growth, white spot, surface redness, and irregular capillary pattern. Differential diagnosis. Qualitative diagnosis is used by magnifying endoscope, and so detail will be explained in the next agenda. This slide describes the finding of SSL by white light imaging. This is typical histology of SSL: serrated architecture, crypt delate, mucus production. I present distinct endoscopic characteristics between SSL and hyperplastic polyp. I will describe the endoscopic features of SSL. Location of SSL is proximal and size of SSL is more than 5 mm. SSL is covered with a mucus cap. Magnifying NBI of the SSL in revealed dark spot inside the crypt in part of the region. Magnifying NBI of the SSL in revealed varicose microvascular vessel in part of the region. Magnifying chromoendoscopy using crystal violet staining identified a type 2 open pit pattern in the region. SSL include dysplasia or carcinoma sometimes. Endoscopic features of the SSL with dysplasia or carcinoma include the following: elevated component, double elevation, central depression, and red color. Endoscopic image of the SSL with high-grade cytologic dysplasia in a representative case. An endoscopic image shows a pale color, flat elevated region covered with mucus at the ascending column. A flat elevated region that had a 13 mm diameter and a dome-shaped double elevation can be clearly seen. The dome-shaped area is slightly red-colored. Magnifying chromoendoscopic view using crystal violet staining. A type 2 open pit pattern is partly evident in the edge of the region. Type 5I mild pit pattern consisting of area with irregular pit can be observed at the dome-shaped area. We endoscopically diagnose the region as an SSAP with cytologic dysplasia and achieve an en bloc resection by perform an EMR. Histopathologic finding with hematoxylin eosin staining of the resection specimen. Part G is SSL. On the other hand, Part H is SSL with high-grade cytologic dysplasia. Endoscopic image of SSL with an invasive carcinoma in a representative case. A conventional endoscopic image captured using white light imaging show a red 55 mm semi-pedunculated region in ascending column. Magnifying narrow band imaging revealed dark spot inside the crypt on the edge of the region and irregular vessel pattern over a large part of the region, respectively. We perform magnifying chromendoscopy using crystal violet staining, a high-powered view of the marginal zone. The dilated opening of the crypt have a type 2 open pit pattern. On the other hand, a high-powered view of the middle region, in which a type 5I severe pit pattern is evident. We endoscopically diagnose the region as a carcinoma associated with an SSL and achieved an envelope resection by performing an ESD. Histopathologic finding with hematokysherin eogen staining of the resected specimen. Part G is SSL. On the other hand, Part H is an invasive submucosal adenocarcinoma associated with an SSL. Invasion depths. Endoscopic features of white light imaging in SM invasive cancer are irregularity within a depression, redness or hardness, concentration of folds, fold crease, erosion, and tension. Difference in pathology standard between Japan and the West. In colorectal cancer, surgical resection of intramucosal carcinoma is considered over-treatment. Therefore, Western pathologists don't like to use the term cancer for intramucosal tumor. In Japan, cancer have been diagnosed based on cellular atypia or structural atypia, with or without submucosal invasion. On the other hand, in Western, tumors with submucosal invasion have been diagnosed as cancer, while non-invasive tumors have been diagnosed as low-grade dysplasia or high-grade dysplasia. In the Western, region within intramucosa is dysplasia, while deeper region is cancer. On the other hand, in Japan, if there is pathological atypia, even intramucosal region is diagnosed as cancer. This table is correlation between depth of invasion of SM cancer and lymph node metastasis. The lymph node metastasis rate of colorectal carcinoma with an SM invasion depth of 1000 micrometer or less was 0%. According to Japanese JSCCR guideline, intestinal resection with lymph node dissection is recommended as an additional surgical treatment if any of the following findings are observed during the histological examination of the resected specimen. 1. Pathological T1B, deep of SM invasion more than 1000 micrometer. 2. Positive for lymph vascular invasion. 3. Poorly differentiated adenocarcinoma, signet ring cell carcinoma, or mucinous carcinoma. 4. Budding grade of 2 or 3 at the site of deepest invasion. The point is as followed. Next, let's talk about colorectal diagnosis magnifying endoscopy. At first, NBI. NBI has been studied by Sano since 1999. NBI used two wavelengths of 450 nanometer and 540 nanometer, which are narrowed by a dedicated optical filter to suppress the reflection of blood, thereby enabling clear observation of superficial vessel and surface structure of tumors. A pit-like structure is a combination of the true pit opening and the marginal crypt epithelium. Because colorectal tumors have many rich and tortuous granular ducts, the NBI light does not penetrate vertically into the pit, and the true pit is not easily seen through the darkness area. Surface pattern is not pit pattern. The surface structure seen in the left NBI image is different from the pit structure seen in the right crypt violet staining image. Surface pattern is not pit pattern. Vascular structure is known to vary with tumor type and depth. It has been reported that the vascular diameter is larger in adenoma than in normal mucosa, and in carcinoma than in adenoma. Normal mucosa is honeycomb-like, and adenoma or TIS is network or dot-like or dense pattern or villus pattern, and T1B is varied caliber or caliber change or avascular area or interruption of thick vessel. Non-magnification cannot determine if it is tumor or non-tumor, but magnification can diagnose tumor. The high confidence prediction of diagnosis for differentiating adenomatous from hyperplastic polyp was significantly higher with magnification NBI than non-magnification NBI and white light imaging. NBI magnification is useful for diagnosis of colorectal region. Diagnosis with NBI non-magnification has a nice classification. On the other hand, in Japan, for extended NBI classification, Sano, Hiroshima, Showa, and GK were in disarray. Sano classification was reported to be able to differentiate between non-tumor type 1, adenoma type 2, intramucosal carcinoma type 3A, and SM deep invasive carcinoma type 3B by observing the microvascular structure of colorectal tumor. The Hiroshima classification adds surface structural findings to the vascular structure of the Sano classification. Showa and GK classification were proposed as vascular classification after 2008. In other countries, magnifying endoscopes were not widely used. This classification is based on the vascular pattern of the Sano classification and the surface pattern of the Hiroshima classification with the addition of color findings. This classification is named NICE classification. And the Janet classification was created in the hope of unifying them. The Janet classification is set up to divide type 2 of the NICE classification into type 2A and type 2B. I will explain in detail each type of Janet classification. Type 1 of Janet corresponds to hyperplastic polyp and SSL. Vascular pattern is invisible. Surface pattern is regular dark or white spot or similar to surrounding normal mucosa. Type 2A of Janet corresponds to low-grade intramucosal neoplasia. Vascular pattern is regular. Surface pattern is regular too. Type 2B of JNET correspond to high-grade intramucosal neoplasia or shallow submucosal invasive cancer. Vascular pattern is irregular. Surface pattern is irregular or obscure. Type 3 of JNET correspond to deep submucosal invasive cancer. Vascular pattern is loose vessel area or interruption of thick vessel. Surface pattern is amorphous area. Diagnostic positive predictive value of JNET is high for type 2A and type 3, but type 2B is low. Diagnostic accuracy of JNET by WLI has the same diagnostic accuracy as NBI. Type 1, 2A, and 3 of the JNET classification were very reliable indicators for hyperplastic polyp, SSL, low-grade dysplasia, and SM deep carcinoma, respectively. However, the specificity and positive predictive value of type 2B were relatively lower than those of others. Therefore, an additional examination such as pit pattern diagnosis using chromo agent is necessary for accurate diagnosis of type 2B lesion. Comparing the area under the ROC curve from magnifying NBI with magnifying chromo endoscopy. Magnifying chromo endoscopy shows significantly higher diagnostic accuracy for depth invasion than magnifying NBI. Accuracy rate of only IEE was 77.9%. On the other hand, diagnostic accuracy of combined IEE and pit pattern increased to 86.6%. I will explain in detail each type of pit pattern CDO classification. Pit pattern type 2 corresponds to hyperplasia or SSL. Type 2 is asteroid pit. Pit pattern type 3L corresponds to intramucosal region. Type 3L is tubular of round pit that is larger than the normal pit. Pit pattern type 3S is the basic pit pattern of the breast region and corresponds to intramucosal region. Type 3S is tubular or like circular of round pit that is smaller than the normal pit. Pit pattern type 4 corresponds to intramucosal region. Type 4 is dendritic or gyrus-like pit. Pit pattern type 5I corresponds to mucosal to submucosal deep invasion cancer, and pit pattern type 5N corresponds to submucosal deep invasion cancer. Type 5I is irregular arrangement and size of 3S, 3L, and 4 type pit pattern. Type 5N is loss or degrees of pit with an amorphous structure. Pit pattern types 3S, 3L, and 4 correspond to low or high-grade adenoma. Pit pattern type 5N corresponds to submucosal deep invasion cancer. On the other hand, pit pattern type 5I corresponds to mucosal cancer to submucosal deep invasion cancer. It includes regions of a wide range of depths. Dr. Kudo divided 5I pit pattern into high irregular and low irregular. 5I high irregular pit pattern corresponds to submucosal deep invasion cancer. 5I high irregular pit pattern has characteristics of narrow lumen, marginal irregularity, and outline indistinct. Left is 5I low irregular, and right is 5I high irregular. Definition of invasive pattern is clearly visualized zone between two morphologically different types of pit. For example, depression, large nodule, or redness area. The region with 5i invasive pattern is diagnosed as deep submucosal invasion. A has demarcated the area and depression, irregular, distorted pit. B has demarcated area and redness area, irregular, distorted pit. Pit pattern classification in all the studies of mucosal pattern with magnification resulted in a pool sensitivity of 89% and pool specificity of 85.7%, and the area under the ROC curve was 0.9354. Strategy to treatment is as follows. Finding of the region. First, the colon is observed with NBI magnification to diagnose JNET. In case of JNET type 2B or a case which is diagnosed to JNET 3 unclearly, colon endoscopy pit pattern observation should be performed. JNET type 1 case should be followed up. Case of SSL, JNET 2A and JNET 2B with 5i non-invasive pattern should be performed endoscopic resection. In case of JNET 3 and 5i, 5N invasive pattern should be performed surgery. First, wash and clean the region. Next, observe region in the far view by white light imaging, median view, and close view. Stain the region by angiocalamine solution in the far view, median view, and close view. The region boundary is clear, and the extension of the region can be seen on the left side. NBI observation is performed after washing out the angiocalamine solution. Surface pattern is observed by mid-range zoom. Surface pattern is regular, and so the region is diagnosed to JNET 2A. Vessel pattern is observed by full zoom. Vessel pattern is a little irregular, and the region is diagnosed to JNET 2A. Finally, crystal violet is stain the region. Stain the region in a slow, gentle drop-down motion. Then, wash with water to remove dirt. Observe the pit pattern, and I diagnose 3S, 3L, and 4 pit pattern. I will present some cases. A voluminous region with a distinct depressed surface. Vascular pattern is loose vessel area and interruption of thick vessel. Surface pattern is amorphous area. I diagnose Janet 3. By crystal violet stain, I diagnose 5-eye invasive pattern. The region has depression area. By NBI magnification, vascular pattern is loose vessel area and interruption of thick vessel. Surface pattern is amorphous area. I diagnose Janet 3. By crystal violet stain, I diagnose 5-eye invasive pattern. The region is LST-NG flat elevated type and strongly erythematous area at the margins. By NBI magnification, vascular pattern and surface pattern are unclear, and so I diagnose Janet 3. By crystal violet stain, pit pattern is unclear too. I diagnose 5N pattern. The region has depression area too. By NBI magnification, vascular pattern is loose vessel area and surface pattern is amorphous area. I diagnose Janet 3. By crystal violet stain, most areas were diagnosed as 5-eye non-invasive pattern, but some narrow areas were diagnosed as 5-eye invasive pattern. The point is as follows. First, you should watch the region. By white light imaging, the region is observed in the far view, median view, and close view. And by NBI, you should diagnose Janet. If you decide to need, you should observe the region borderline and surface irregularity by angiocarmine staining. And by crystal violet staining, you should diagnose pit pattern. Always diagnose using a magnifying endoscope. When in doubt about the diagnosis, don't hesitate to use dye magnification. Thank you.